to our first panel session of the day, and our one that we're excited about for a variety of reasons. We're going to be talking about how training, modeling, simulation, things like that are now playing large roles in a variety of areas in Homeland and training initiatives and so forth. With this panel, I'm real excited to have coordinating for us Sandy Peavy. Sandy was the first CIO at the Federal Law Enforcement Training Center dating back to 1999, and I believe the longest tenured CIO in DHS. I think that's an accomplishment. The way CIOs come and go these days, Sandy's been in the role since 1999. She also, in her past, worked quite a bit on the Treasury CIO Council, and they were fun days because I happened to be at Treasury at the time. She's done a number of things in her career. For example, she worked for the Air Force Reserve Command. She was Deputy Director for Communications and Information there. But what's also interesting to me is Sandy entered the federal service as a GS3 and has made her way through the years to the very top of the pay scale, which says something about her abilities, her motivation, and her overall skill set. But more exciting, Sandy is a fun person. She's a pilot, she flies. Tried to get my wife to let me fly, and she using Sandy to try to encourage that, but my wife said she wouldn't even get in a car with me, yet alone get in an airplane with me. But everybody knows Sandy. She's well known around town. She's liked by everybody. She's always upbeat. She's the happy person. I admire her for her remarkable career, and I consider her a very good friend. So we're very, very lucky to have with us for this panel Ms. Sandy Peavy.
Thank you very much, Jim. I'm very excited to be here, and good morning to all of you. With me here today, I have Dr. Benjamin Hamilton from DOD and Dr. David Boyd from S&T. And you're going to have a rare opportunity today to hear how and why we are using modeling and simulation to help protect our homeland from a law enforcement, a military, and an emergency management perspective. One of my very favorite sayings is that timing is everything. And with the economic turmoil that we're finding ourselves in today, where we have to simultaneously reduce costs while protecting the homeland, I believe that we're now in a period when modeling and simulation and virtual reality methodologies are not merely an aid to live training, they are now indispensable. So I'm going to begin today by talking to you about modeling and simulation technologies that we're using at FLETC, some of the challenges and opportunities that we have from a law enforcement perspective. And then I'm going to turn this over to my esteemed colleagues, and they're going to discuss how we're all using modeling and simulation as we work toward providing a safe, secure, and resilient environment where the American way of life can thrive. I want to talk to you a little bit about FLETC itself. FLETC provides law enforcement training to 92 federal organizations. Plus, we do state, local, tribal, and international law enforcement training. It includes organizations that you're probably very familiar with, such as Secret Service, CBP, ICE, U.S. Marshals, one I know we're all familiar with, IRS, Capitol Police, Pentagon Force Protection, NCIS, we do the Federal Air Marshals, and Bureau of Indian Affairs. Well, don't worry, I'm not going to sit here and name you all 96 of them, but I will tell you that last year, 76,000 students came through our training center. Although we are a component of DHS, less than 15% of our workload is DHS. Well, and I know from my accent that you may think that our headquarters is in New Jersey, but you would be wrong. We are actually located in Georgia. We're halfway between Savannah, Georgia, and Jacksonville, Florida. And our other sites, as you can see on the slide here, include Artesia, New Mexico, Charleston, South Carolina, and Cheltenham, Maryland. And we also have international presence in Botswana, in Bangkok, Budapest, and El Salvador. At this time, what I would like to do is to show you a brief 3-minute video of some of the modeling and technologies that we are implementing at the Federal Law Enforcement Training Center.
Law enforcement training is in a constant state of change. It's important to not only stay current with techniques, but to also look at new technologies as a way to support and provide training to new law enforcement trainees. The Federal Law Enforcement Training Center is at the forefront of law enforcement training. Here to talk about some of those new technologies is Jason Kirkendall, a senior instructor of the Behavioral Science Division at FLETC. Hi, Jason.
Hi, Patty. How are you?
I'm doing great. Tell me about some of these technologies that you guys are using right now.
Well, here at FLETC, we use a number of technologies in different training programs. For instance, we use training in, or simulation or technology training in driving, marine operations, tactics situations, and also in interviewing.
All right, now what about desktop simulator? How do you use those?
Well, desktop simulation is extremely important in the tactical arena of training. What you would allow the student or the trainee to do is an opportunity to plan out their situation specifically so they get practice before they actually get to that situation.
And advanced use of force training, how does that work?
The advanced use of force training system is a system designed to help the student in judgment-making decisions. Any use of force scenario that they may encounter, this will allow them to practice that skill that's extremely necessary in the field.
And you also use holograms.
Yes, the tactical digital holograms are the exact same thing as the desktop simulator as far as where they tie into our training, into our tactics training. Allow this trainee or the student to focus in on some of the planning stages prior to going out to the actual situation.
Okay, now how does the avatar system work?
Yes, ma'am. We're excited about the ABIS for short. The ABIS is a fully interactive, fully immersive environment in which we will help reinforce our current training in interviewing. Let me introduce you to Heidi first. Okay, this is Heidi. Hello, Heidi.
Hello.
Hi, Heidi.
Hello.
And where are you from?
I live in Waldorf, Maryland, with my parents while I go to school. It is quiet compared to the dorms.
Oh, that is great. How many questions can she answer?
Well, it's a number of questions and a number of question-answer variations. Currently, we're near 15,000.
So whoever is asking the question gets a lot of practice, they can hone their skills, and she's actually a witness, right, to a crime?
Correct. Mm-hmm. She's part of a scenario that we've built that will include 4 interviews. And the first one is a victim/witness. She saw her best friend being kidnapped at gunpoint last night. And so she is partial victim, partial witness, but she has a lot of information that the investigator needs to get.
Now, you mentioned the questions. She's prepared to answer a lot of them. But what about some of her body movements and her gestures? Is that part of the avatar system too, understanding the way she's moving and what she's doing?
Absolutely. We all know that nonverbal communication is extremely important and also a big part of how we communicate. So we've spent a lot of time in programming specific nonverbal behavior to show specifically stress in the environment that she's feeling right now.
All right, very nice. Thanks, Jason, for talking to me about the future of law enforcement training at FLETC.
Thank you very much, Patty.
Okay. What I'd like to do is take a few minutes and go over some of the things that you saw here on the video, because I know it was hard for some of you to see. It's one of these things that you put it up and you do beforehand, and then you come and you realize that it's maybe hard for some of you in the back especially to see. So some of the things that we were talking about here, one of them is your driving in simulators. We're integrating them into a lot of our programs now. Anyone care to guess the cause of most officer fatalities? Anybody? Car crashes is driving. Since 1998, more officers have been killed by vehicle crashes than by gunfire. and most of that is contributed to distracted driving. So we have approximately 60 simulators at our site, and we're using them to augment our live training and teach these officers how to handle distracted driving, such as what to do when they're on the radio going at high speeds and they have a computer and they're going through intersections that they have to clear. And so really we're using the simulators not to teach them how to drive, but to put them into decision-making scenarios. And these things will help them not only better accomplish their mission, but it will help bring them safely home to their families at night. In fact, I just saw on the news today that there was an officer here that was just involved in a fatality. Luckily, the officer wasn't killed in the process with this. You also saw about our use of force systems, and that the use of force incorporates speech recognition with law enforcement vocabulary. So what they're doing here is they're trying to, you have the perpetrator, and they're looking at, they need to apprehend this suspect, and so they're actually being able to talk to him and watch his responses so they can decide which is the best use of force to be able to get him, whether it's going to be through a gun, a nightstick, or a taser, or they're just simply able to talk him down. We're doing a lot with our tabletop simulators, and this is really helping officers train on identifying and reporting suspicious activity. And we have one called Ambush, and that provides protective service training. I mean, think about it, you got your Secret Service, you got NCIS, and you got your State Department, and that's helping them with the protective service. We're also in the process now of constructing a firearms simulation range. This is going to augment, we have loads, I don't even know what the number is, of firearm ranges, and this is going to help augment the live fire. We're having 72 lanes installed at substantial life cycle savings. It's going to take up less space, has less environmental impact because of the lead, and it's also going to save us on the cost of ammo. All right, I told you that we have 76,000 students. Anybody want to take a guess at how much ammo we use a year? 17 million rounds. So this is not going to only help with the cost, but it's also a very effective way of training, because research is showing that simulation for your basic marksmanship is equally as effective as live fire. And here's the thing that's counterintuitive to me, but what the research is showing, that when these officers have to requalify, the ones that have gone through the simulation are actually requalifying better than the ones that just were trained using live fire. The next thing I would like to talk to you about are some of the challenges that we have in trying to implement this technology. The first thing is, just like you see on television, your criminals are very tech savvy. And they're often the earliest adopters of all the new technologies that are out there. So by the time that we actually develop, implement, and train on these new technologies, the bad guys have already moved on to the next ones. Also, the broad mission space that we have with law enforcement. You know, as I mentioned in the beginning, our law enforcement officers span the gamut. We have state, local, tribal, international. The issue that we have is there's no centralized decision-making body. So what that means is that we usually end up with costly, non-operable systems that don't allow us to train together. And then one of the biggest challenges from my perspective as a CIO is that your virtual worlds, virtual reality, modeling and simulation can be extremely costly and vast. I mean, there's just, you name it, and there's a simulation out there for it. So what we're having to do is to look at how do you identify the right mix of live, virtual, and courseware delivery methods. The next slide I want to talk about are a few of the opportunities. We need systems developed for open source, open standards, and non-proprietary to service the broad customer base I've been talking about. Now, the good news is that that should translate into economic opportunities, not only for industry, but for the government. You know, you do it once, and then you've got a broad base to put this out to. The next one is that we need agile development within 3, 6, or 12 months, because deliverables, when by the time that they're developing a fully deliverable system, as I said earlier, we're already out of the game. For those of you in industry, we need your help to bring in some commercial technology to our law enforcement mission. Examples include gaming and plug-ins or tailoring of commercial or other government applications. For those of you in other government agencies, we need to align our efforts to establish priority and leverage investments so that we can allow law enforcement to train together and with other government and coalition partners that help protect our homeland. What I want to do is I want to use the avatar that you just saw in the video as an example. Of course, we all know technology is changing the way that we communicate today, and especially with our kids. You know, how do the kids communicate? They're on their cell phone, they're communicating with their thumbs. They don't have a lot of face-to-face interaction. Well, interviewing is a very basic law enforcement task, and it used to be one that was easily taught. Well, now our students are struggling to demonstrate this proficiency. So that's why we came up with Heidi. We figured since they were using technology that we would turn to technology to help us with the answer to this. We reviewed a lot of systems that were out there, and we decided to modify one that the Army has, and you'll just love this. It's called the Army's Human Intelligence Control Cell Simulator. Go figure. The main reasons that we chose this is because it was already a proven technology. The Army had 16 scenarios that they had already developed, and they were getting positive user feedback, and 10 systems had been fielded, and they had another 200 planned. So it was proven technology. The rapid deployment that I talked about. We contracted with industry to tailor the application for law enforcement scenarios, and we started this in June of '09, and the prototype was delivered in March of '10, which was some 9 months later. And probably one of the most important, especially for small as FLETC is that the cost was right. The R&D investment by the Army had been substantial, and for just a little over $1 million, we were able to adapt the system for our needs. So the bottom line here is that this turned out to be a win-win for everybody. Industry was paid to modify the system. They gained insights that they could potentially reuse. FLETC got a system that met their needs with a minimal investment. And because we are the SMEs with interviewing, the Army liked what we did to the system, and now they're putting it back into their system. And oh, by the way, industry's the one that's helping them to do that. So one last thing that I want to talk to you about with that application, Heidi is a standalone system. It takes approximately 30 minutes for a student to go through the scenario. Imagine what we could do if we were able to put that on a mobile device where these students could get to that type of simulation anywhere, anytime. The next slide that I wanted to show you here is from Royal Canadian Mounted Police. We had actually invited them to be on our panel with us today because we're doing a lot of research with RCMP. And the reason that I'm showing you the slide is to go back and talk about the broad economic opportunities that you have, because it's kind of hard to see, but at the very bottom of the slide is a driving simulator. This is the exact same one that we use at the Federal Law Enforcement Training Center. We have 60 of these. So, and it's not just the equipment, but the scenarios that you're developing can be then reused. Now, you've seen FLETC, you've seen International. We talked about the state and locals that have just had a car incident. So with the broad scope that we have with law enforcement, if you develop it once, then there's an opportunity to sell this to many. I'd like to conclude with a little bit of contact information. And because we're a little late, I'm not going to go into some of this because I think a lot of you in the audience probably are already very much aware of your Fed BizOps and our DHS website. I do want to tell you that FLETC does use that a lot. So even though it's a familiar tool, I encourage you to use that. The one thing that you may not know is about our FLETC website. Here you're going to find small business contacts as well as information for our acquisition planning forecast system. And the one that I really want to call your attention to is we have an email, and it's called innovation@fletc.dhs.gov. If you will email any of your ideas or questions or anything that you have, my people monitor that mailbox, and I promise to you that we will get back with you on anything with, we very much welcome your ideas and your questions and your thoughts. So, to wrap up, if you take away anything from my presentation today, I hope it's the fact that we simply can't do this alone. On average, one law enforcement officer is killed every 53 hours. We have a FLETC memorial with the name of 189 law enforcement officers that had been killed in the line of duty. And in fact, we were just notified yesterday that a Bureau of Prison guard that we had trained has just been killed by an inmate. So we need industry, we need other government agencies to partner with us and to help us reach our goal of never having to add another name to our memorial. So thank you. And at this time, it gives me great pleasure to introduce our next speaker, which is Dr. Benjamin Hamilton. Dr. Hamilton is a program manager for the Technology Training Development Subgroup at the Combating Terrorism Technical Support Office. His expertise includes analyzing, designing, evaluating, and managing projects involving interactive instruction, performance improvement, and simulation game-based training. His undergraduate degree is in mathematics. His master's degree is in instructional technology from Bloomberg University, and he has a doctorate of education in instructional technology and distance education from Nova University. So, Dr. Benjamin?
Well, good morning. As Sandy mentioned, my name is Benjamin Hamilton, and I'm a program manager for the Training Technology Development Subgroup at CTTSO. I'll describe a little bit about what that organization is in a little bit. And unlike Sandy, I'm not going to apologize because some of my slides are very tiny. So I trust if you sit in the back, then you have eagle eyes and you'll have no problem seeing these. To start, just to give you a little lay of the land of where our organization is, we fall under the Assistant Secretary of Defense for Special Operations and Low Intensity Conflict, ASD-SOLIC. Underneath that, you have the Combating Terrorism Technical Support Office, and underneath that, there's 3 programs: the Technical Support Working Group, the Explosive Ordnance Disposal Low Intensity Conflict Group, and then Irregular Warfare Support. The Technical Support Working Group is the oldest organization, and they were kind of the genesis of all this. They can be traced back to about 1982, when there was some national security directives that assigned responsibility of coordinating interagency projects to the Technical Support Working Group. In 1999, the Combating Terrorism Technical Support Office was set up to give oversight to TSWG, and then along the way, 2 other programs were also added. You'll also see a dotted line to the Department of State. That's because we have some international bilateral agreements, and we have bilateral agreements with Singapore, Australia, Israel, Canada, and the United Kingdom. And those are agreements where we will cost share different projects 50-50, and we'll use that time and those projects to actually fund joint needs that both countries have. So this is our mission. You can see our mission and vision. Really, the goal here, the main takeaway is that we are an organization that identifies and prioritizes interagency requirements that solve combating terrorism needs. So we work a lot with end users. We develop capabilities for frontline users. We do RDT&E, research and development, testing and evaluation, and we work with industry, academia, and national labs to accomplish these requirements. You can see some of the objectives: providing interagency forum for coordinating R&D. So much like Sandy was saying, we're an organization that brings together different agencies to coordinate these combating terrorism requirements. We have funding, so we sponsor interagency and advanced technology development. We focus on, since we are an RDT&E organization, we focus on getting these funds out to, or transitioning these projects out to the end users, who will then pick it up and sustain it from there. A lot of the projects we also do influence policy development, and again, a lot of this will guide basic and applied research as it comes in. So we're normally dealing with 6.3, 6.4 money, if that means anything to anyone in here. The Training Technology Development Subgroup, so drilling down a little bit lower, underneath the TSWG, we have the Technical Support Working Group. There are a bunch of different subgroups that work underneath there. There's one group that's focused on chem bio. There's one's focused on tactical operations support, surveillance collection, physical security, personnel protection, investigative support and forensics, advanced analytics. So we're the subgroup that focuses on training technology development. And so our focus is satisfying interagency requirements for combating terrorism-related training, education, and mission performance improvement technologies. We have 3 focus areas: advanced training and education, which is everything from new concept development and developing new programs of instruction. Models, simulations, and games is just how it sounds, and I'll be focusing a little bit more on some of our projects within those focus areas later on. And then training, information aids, and devices. So these are performance support projects, things that don't require a huge new program of instruction or anything like that, but something that just with job aids and performance aids that can get the job done. And then those are our team members there. I have a team of 3 other people as well. On our business cycle, this is kind of how we operate as an organization. Really, our process starts at the 9 o'clock position, where we have a requirements meeting. So each year we'll bring those members of the interagency community together to identify what requirements they have for the upcoming year. And then we'll give each agency a time that they can present that, have other members ask questions, and then we'll rack and stack those requirements and prioritize them, and everybody will vote on those. From there, what we will do is we will write up our requirements into the broad agency announcement. We actually have a broad agency announcement out there right now, so if you go to FedBizOps, you should be able to search it, or if you go to www.bids.tiswg.gov, you'll be able to find that too. You can click on click on the BAA link, and you'll be able to see that. So that lists all the requirements that were brought to us from that requirements meeting across all the different subgroups that we have. So so that's out and open right now. We're waiting submissions that come in from industry, academia, national labs, and the submission is just simply a quad chart. So it's a one-page quad chart that provides all the technical details and the estimated cost for that specific requirement. From there, what we'll do is we'll down select to white papers, and we'll down select further to full proposals. And the intent is that by the time we get a full proposal, we're actually going to be funding whatever it is that we've selected. And then from there, we work on project initiation and continue. And at the middle, you'll see sponsors, end user, subject matter experts. Our process doesn't work without the active engagement from subject matter experts and from end users too, they're the ones that are driving these requirements, and they're going to be the ones that use these projects or these whatever is developed at the end. So I'm going to get into just a few project highlights, and then I'll talk about some challenges. First is a tactical driving simulation. We had seen the FLETC's system as well. This was a requirement that was brought to us by the Pentagon Force Protection Agency, Diplomatic Security, Department of State Diplomatic Security, and the United States Secret Service. And the intent here was just a simple desktop simulation that focused on motorcade formations. So teaching them to go through the process of how do they deal and they move and communicate within a motorcade formation. So it's not a large footprint. In fact, Department of State wanted it specifically small so that they could ship this around to different facilities that they had. It was, again, it has a range of programmable scenarios and focuses on that cognitive skills and situational awareness rather than a more psychomotor simulator designed to teach or to teach students how to operate the vehicle. Gunfighter's Gym. This was a project that was built on pro sports training methodologies. So the company Conflict Kinetics has kind of a foundation in pro sports training. And basically it runs trainees through a series of performance improvement drills and situational drills that are designed to increase their visual and situational awareness. Some of those drills include a 220-degree 5-screen laser system that you can see there in the picture. There's also movement drills, conditioning drills, and then ocular eye tracking and target recognition drills that students will go through as a series. And we've been able to see, basically what we're seeing is that soldiers and warfighters that are going through this are able to increase they're able to process information faster, and they're able to keep forward momentum in assault-based operations. So it improves their accuracy, the speed, and the number of targets that they're all able to engage. Again, we've seen some quantitative increases in the speed, accuracy, and the number of targets that they're able to engage. And we've also heard some qualitative feedback from users who were able to engage targets faster at a live range as well. The Minigun Simulator, if anyone's familiar with a minigun, depending on how it's configured, it can shoot around 3,000 rounds per minute. So you can imagine that training with live ammunition on this is a pretty costly endeavor. So we worked with the 5th Special Forces Group and the Department of Energy to develop a high-fidelity simulator that replicates the form and the functionality of the actual weapon system, and then integrates it into a 3D environment where they can engage virtual targets and they still go through all the malfunction and the operation drills, the loading procedures that are required of the minigun. The Department of Energy did a quick analysis, and they found that they could save about $1.8 million just in ammunition savings alone as they're going through qualifications and things like that. Parachute Simulator. This was a simulator that was focused more on not necessarily the cost, but more on the health and the life and safety of special operations. So basically, what SOF was finding, Special Operations Forces were finding, is that there were a lot of injuries and unfortunate deaths that were happening as a result of malfunctions and emergency procedures that needed to take place when a parachute opened that weren't being done. So they wanted a safe environment that they could practice a lot of these, and that they could put students in, that they could see a lot of these different malfunctions that were going on before they actually are standing on the end of a plane and jump out the back of it. That's not when you want to figure out how to solve an emergency procedure on your parachute. So we have a handful of different systems. down at the Special Operations Mission Training Center at Fort Bragg. And SOCOM is actually looking at, Special Operations Command is actually looking at making this into a program of record across a lot of the soft components. On the modeling portion, so CTTSO, some of our sister subgroups develop a ton of different technology. And what we're seeing is that when, sometimes there's just a user manual that's provided with a piece of kit or gear, and well, that user manual gets separated very easily from the actual piece of equipment. So we were looking at doing a mobile app for some of the technology that we're developing in house. It provides a 3D model and provides a job aid so that users can quickly query up what the device is, what technology it is that they're using, and get information and instruction on how to operate that, some of the procedures that are required in operating that particular piece of kit. And then a foreign weapons application is a project that we've been talking with FLETC about as well, and I know they're working on some things, and actually RCMP is interested as well. These are, from the soft standpoint, the goal here is to allow soft armorers and weapons specialists the ability to conduct advanced maintenance on some of the foreign weapons that they come in contact and that they're pulling off from other countries. Again, we've been working with FLETC, RCMP on this effort, and continuing to leverage some of the work that they're doing, so that we, basically between all of us, we would just want to make sure we aren't duplicating any weapons that are being conducted. So that's another great example that Sandy was talking about of partnership. In conclusion, I just want to highlight some of the challenges that we see. First of all, the instructional system design process. One of the main points here is that we need to maintain ISD best practices. If some of you aren't familiar with ISD, it's just the systematic design of instruction. It's a way of designing the instruction, developing the instruction in a way that meets a lot of the learning methodologies that are out there and that have been thought of. So, the focus needs to be on maintaining those ISD best practices, particularly with the analysis. What we've seen in some of our projects is that the analysis can be more data intensive than a typical ISD project where you're doing something for either a program of instruction or a computer-based training. Additionally, the audience analysis can be especially challenging, since there are added dimensions that need to be considered. There needs to be technology self-efficacy. There needs to be the motivation, readiness to use new technology that all are incorporated within the audience learning needs analysis. Objectives. Anyone that's designed training before knows that there needs to be a huge emphasis on what the objectives are of the training. So we were seeing simulation gaming worlds and ISD worlds kind of starting to blend together. So there needs to be a focus on maintaining what the training outcome, what the training objective is for this simulation. So it's not just something that's out there and looks good and it looks nice, but has really no training value to it. And additionally, that kind of piggies back off of evaluations as well, because the evaluations need to tie to objectives, and we need to avoid the syndrome of just collecting everything, because the simulation can collect everything, but really focus on what metrics are needed to identify whether or not the objectives are being accomplished. And then funding. Sandy already mentioned a little bit about what's going to happen tomorrow, but just in terms of upfront cost. There's computers, servers, licenses, developing custom scenarios. It's simulations and simulators and games and models. They aren't necessarily cheap, but through partnering with other agencies and to identify the common needs, you can avoid developing multiple systems, multiple simulations, within each organization, within each stovepipe. Another issue that comes in with funding is actually scope creep, and we actually see this pretty much on every project that we deal with. We see end users getting excited about what the technology can do, and they want more and more of it, so they get really jazzed up about that. And then we see on the vendor side, we see contractors that are excited and passionate about what they do. So they want to insert their own features. They want to show you how the tree bark can fall off a tree because it's hit by a car or something like that. I mean, that's great, but what's again, going back to the ISD process, what's the training value that provides? Scope creep is a big thing. Expectation management. With this one, what we see, we often get asked the question, well, I want something like Modern Warfare or Grand Theft Auto. I mean, why can't we have that? My kids are playing this. Why can't I have that as well? So what I usually say is I give the example of Grand Theft Auto. When that came out, Grand Theft Auto 4, it cost a couple $100 million, tens and hundreds of millions of dollars to build. But they made that back within just the first couple of weeks of selling that game. And so here you have a game that cost more than most DoD training budgets would be able to provide for that. And yet they were able to make that back very easily. And that's because working in for-profit companies it's a lot different than trying to do something for the Department of Defense. A lot of those game companies understand that, and they're going to go oftentimes where the money is. We also see with expectation management, fidelity. It needs to be, again, going back to what the training objective is. It needs to have a high enough fidelity that it accomplishes what it's supposed to. It needs to be realistic, but you can't be spending hundreds of thousands of dollars just trying to accomplish that last level bit of fidelity to make the tree bark fall off the tree in the right way. When there's other things that are needed instead of that. Change management. This is a common concern that we have in model simulations and simulators. It's that fear that the simulation is going to replace hands-on training. In some cases that might be the case, but more often than not, it's going to augment hands-on training or live training in some respect. Also, what we see within change management is there's oftentimes a resistance from management with introducing this system, this simulation. So we need to make sure that the departments and agencies have a well thought out plan for how it's going to be integrated, and not just assume it's going to be well received. And then that kind of goes along with end user engagement as well. For us, again, end user engagement is key. Simulations require constant end user engagement throughout the entire process, because they're going to be the ones that get the simulation or the game at the end of the day. Again, because we're an RDT&E office, our funding only can get us so far before O&M needs to pick up, and those users need to be well aware of what the costs are to sustain that and carry that forward. So those are some of the challenges that I had. My contact information is up there. If you want, you can write it down really quick, and I know we'll have a little bit of time for questions at the end. So I appreciate your time and look forward to your questions too.
Thank you very much, Ben. I'm really glad that my husband did not know about the parachute simulator, because as a special forces person, I decided about 3 years ago that I wanted to jump out of the airplane, and I didn't tell him till after I had done it, and he was not happy with me. So if he had known about that, I would definitely not gotten to jump out of that airplane. At this time, it gives me great pleasure to introduce Dr. David Boyd. Dr. Boyd joined DHS in March of 2003 and serves as the Director of the Office of Interoperability and Compatibility, and is the Director, Technology Transfer, with responsibility for R&D programs to support communications, interoperability, space-related issues, and other first responder technologies. Before joining DHS, Dr. Boyd served as the Director of Science and Technology for the National Institute of Justice. His office managed R&D programs in every facet of technology affecting law enforcement and corrections. And before entering civil service, Dr. Boyd served more than 2 decades in the U.S. Army. He has commanded combat support, and training units in the United States and overseas, and has served on military staffs from battalion level to the Pentagon. He holds graduate degrees in management and public policy analysis, as well as a doctorate in decision science. Dr. Boyd?
Now, the dangerous part here is seeing whether I can actually manage the slides. You should never trust a technologist with technology. I want to take a little bit different tack on this. I'm going to tell you a bit about my office, as we have to do. But I want to take a little bit different look at modeling and simulation beyond just training. We're obviously interested in training as well. We are S&T, so we're the S&T for FLETC as well. We are concerned with things like slosh models, what happens when the storm surge occurs in a hurricane. We're interested in the whole variety of things that you might simulate. But I want to talk about one particular category that's been of great interest to us now for quite some time, since well before the Department of Homeland Security stood up. My office has that term interoperability and compatibility in it because Congress back in 2004 created the office. It actually was an offshoot, for those of you who may recall, the SAFECOM program, which still exists, but was the forerunner of the Office of Interoperability and Compatibility. And what we were charged with was trying to identify everything from the technologies, all the way through the RDT&E, through the standards and the rest, to establish interoperability of communications. Now, think of communications in a big picture. It's not just voice communications. It's voice, it's imagery, it's all of the kinds of things that you might need to exchange. The notion is, how can I get it from where it is to who it is who needs it? Now, we look at modeling and simulation as a way to reduce costs, as a way to look in our environment at everything from network scenarios to communication scenarios, to try to figure out how we put that together. And one of the reasons we're heavily involved in this now, and I'll give you a couple of examples, is that how many of you here are familiar with FirstNet? Ah, good. So I won't have to explain too much about it. FirstNet is a new nationwide public safety broadband network. Congress directed its establishment last year and set aside, sort of, some funding to put it together, about $7 billion, $2 billion of which they can borrow against auctions which have not yet occurred, and $5 billion of which they can get from auctions which have not yet been scheduled. The FirstNet is intended to be a nationwide way of providing a set of the ability to do the kind of broadband things that public safety has never been able to do before. Exchange data, exchange imagery, exchange voice as well. There are a number of issues associated with FirstNet having to do with things like LTE, which is the protocol they intend to use, does not yet support mission critical voice. So we're going to have to figure out how we address those issues. LTE is essentially a cellular kind of commercially based sort of approach. So it doesn't meet, in every case, public safety needs. It doesn't necessarily meet the robustness challenges. What happens when a typical cellular system encounters a major emergency, and that is that it ceases to be functional for most of the people who are involved. Not usually because the system collapses, but because the number of lines available get locked up and you can't get back into the systems. So for that reason, public safety is looking at it in a different way. But it's important also to remember that while we look at this, this is a finite resource. It's only a 10 megahertz pipe. It's 10 up and 10 down. You hear it talked about as a 20 megahertz spectrum allocation, and that's true, but that's only a 10 megahertz pipe, not a really big pipe. And in fact, not a big enough pipe to be able to support all the things that the 2+ million first responders would need to be able to use in emergencies, except possibly in some of the more rural areas where currently no such capability exists. Now, it's important to think about the kind of things that we're going to have to be able to solve for this network. It's going to cost a lot of money. I don't know how much attention you've spent are paid to what it costs to put something like this up. A very inexpensive site for an LTE network or for a cellular network for that reason is about $250,000. That's a very inexpensive one. The actual costs average somewhere between 2 to 5 times that. We estimate that for FirstNet to provide the coverage they're promising right now, they will need to build at least 30,000 additional sites over what the commercial systems currently provide. That's expensive. There's no way to make this inexpensive. That means that we have to think very carefully about what we do. Now, I'm going to talk to you a little bit about some of the assumptions people make. A lot of folks like to look at the commercial network propagation maps. Those are these maps that say, here's what our coverage is. The one you see there on the left is one of those propagation maps. These are what we call an RF propagation map. That's where the RF goes under perfect conditions. That's the coverage you're going to get. That's what you'll get. You'll be able to detect RF in each of those places. And that's the map they're always going to show you. They're never going to show you any other map but that one, because that is the most optimistic map you'll see for coverage for any cellular system. One of the things that we've done some modeling with, first, we did a lot of data collection, did a lot of experimenting, took a look at what happens. When you put loading on it, let's say we've got an emergency and we start using these things, the map on the right side shows you what the coverage becomes. Only the yellow space is the coverage, and that's because, as we talked about, when you have a major emergency and they lock up the systems, as people begin to tie these up, the systems that are, the devices which are closest to the tower wind up seizing the tower, and now I lose communications over this larger area because there aren't enough lines there to provide that. So one of the things that we need to be able to model as we begin to figure out how we're going to place our facilities, because remember, it's a lot of money. We make mistakes. We're going to cost ourselves huge amounts of money. One of the things we have to be able to model is what happens in an emergency when you load it, because that's the thing we care about. We don't care about the normal day. We care about what the old phone system used to base their carriage capability was on Mother's Day, because that was the day when everybody made calls. We care about what happens when that disaster occurs. Now what happens to the communications, and how now do we have to design where those sites are going to be. And then we have another issue that we find interesting, and that is, remember I told you those neat RF models again. The one on the left, all that green space, that's that RF map. That's where the propagation goes. You can look at it, that's where the RF would go, except that in that area are buildings and trees and other structures we call clutter. And when you take the time to actually test the clutter, then what you find is the coverage drops dramatically. So that while the theoretical coverage in a propagation map is really good, clutter dramatically reduces that. And that clutter changes because they put up new buildings. In the summer, we have a phenomenon called leaves. We sometimes have, and of course you can have momentary things like snowstorms and very dense fog, which, as you probably know, as you go higher and higher in spectrum, the greater the impact of those things is on the signal. So we need to be able to model those things. We need to be able to simulate what those things are before we make the investments to put things into place. Now I'm going to turn things just a little bit, and I want to talk about how we can also do modeling and simulation, and how we do without having to build new software, without having to build new mechanisms. And by the way, before I leave this, I want to tell you that one of the things we're working on now is kind of a low resolution, quick and dirty, real-time model that an emergency manager can use, so that when he loses part of his communications facilities, he can model quickly what the damage is without having to go out and start calling everybody and see if he can figure out who he can hear and who he can't. And model in advance what will happen if he puts, say, a cow, a cellular on wheels, in a place to help cover it, or a portable repeater station, and where could he put it to best provide the kind of coverage he needs. Now, a lot of you I know want to do business in the state and local environment, and lots of you are building things that you want to sell to state and local. I'm going to tell you some hard truths about that business as we get into the kind of modeling that we're doing here. First, It's important to understand, and I'm going to use Virtual USA as a model. Virtual USA is how can we exchange information among disparate data systems? How can I do that? Primarily GIS-based data, and how do we do that? Now, but before I start with that, I also want to focus on why we focus on state and local. And I know that little thing on the right side is kind of small, but follow me through. Our experience as we collect data is that in 87% of critical incidents, even tornadoes, even most hurricanes, that kind of thing, only the local jurisdictions involved. 87% of the time, only the local guys involved. So if you wonder why he resents it when you come down and tell him how to manage emergencies, you can understand it's because he does them all the time, we only do them rarely. The state is involved in about 11% of the cases. And when I say involved, I mean involved, not in charge, not managing, involved. They might have one representative there, they might be providing a few resources. In only 2% of the cases is the federal government involved, and I use that word involved again. The state and local guys drive it, it's their resources, it's their communication systems, it's their emergency responders, it's their money, it's their community. So it's crucial we start with them. So what do they tell us when we tell them that we want to help them resolve this problem of information sharing with adjacent jurisdictions? Well, they tell us a couple of things. It can't be a federal mandate. We can't dictate to them how it's going to happen. They're not interested and they won't talk to us about it. Second, they're looking for a blend of both process, which is often the hardest part, and technology. And they want to start with a couple of things. Basic rules, and probably the easiest way to understand it is they can't change out the current platforms, they can't change out the current software, they can't change out any equipment. You got to live with what they got, period. And in Virtual USA, that's what we've been working on. How do we manage to make that happen? So I want to show you an exercise, and this is kind of an inexpensive model. What happens? How do you model something before it happens? This was in the Earthquake Consortium, what we call CUSEC, which is the Central United States Earthquake Consortium, 8 states. These folks had a variety of platforms. They had Silverlight viewers and Adobe viewers, and they had Google systems, and they had Esri systems, and yet all of them could see the same picture, even though they're coming from a wide variety of states. And so what you see there is road information from all of these different states, Indiana, Illinois, Missouri, and it's real time. Not only that, it's dynamically displayed because we figured out how to do it without making them buy new equipment, change out their software. We've been able to make that happen, which then causes them to be interested in participating, because the instant you tell them you got to throw away that thing that you've spent the last 5 years building, and you got to go tell your state legislature, your county commission that you really screwed it up because DHS and the federal government have a better idea and you ought to adopt that. You can imagine how many local managers want to do that. So you're going to have to, plus they can't afford it anyway. There's no money there and we no longer provide grants. This also becomes a real simulation because this is a simulation. It wasn't a real earthquake. It was, given the scenario, given the exercise, and often an exercise is the simplest, cheapest, and sometimes most useful scenario. We did one of these in Eastern Virginia around the Norfolk, Newport News area. And one of the things we discovered about a year or so ago was that all of the DoD facilities and the state of Virginia had decided that they were going to do their evacuations on exactly the same routes at exactly the same time, but they weren't coordinated. Now that exercise, that simulation, and in this case using this kind of information and this kind of modeling, allowed them to deconflict those things. And so they've worked out a way to accomplish what they need to be able to accomplish. When you get old, it's hard to remember what you're going to say next. We also have an experiment we're currently conducting, and we're calling it experiment because we want to allow the possibility of failure without anybody being responsible for a failure. And experiments sometimes succeed, sometimes they don't. So we're not calling it an exercise. We're not going to exercise something. It's an experiment. And what we're looking at here is how we can achieve this interoperability cross-border, U.S. and Canada, involving a variety of packages, some of which you've heard of, with the Canadian MASSAS, the Multi-Agency Situational Awareness System, which was based on Virtual USA, the Integrated Public Alert and Warning System, IPAWS, and a number of other things that already exist at the states, their own systems, and in the provinces in their own systems. And in fact, I'll be there for this experiment next week, depending on what happens with the sequester tomorrow. Now, with that, what I want to suggest to you is that think broadly about how we can use modeling and simulation, and think in terms of two things. One is that we want to be able to use it to dramatically reduce cost for obvious reasons, or to prevent us from making costly mistakes. We also want to be able to use it to do rational planning and deconflicting of plans, and to figure out how we're actually going to do things. And then finally, we want to be able to use it on a real-time basis when we can, so that they can help emergency managers make intelligent decisions while the disaster is occurring, not just in the planning environment up front. Because every disaster starts out as a plan on a piece of paper and then turns into an ad hoc scenario as you begin to execute it. So we need to be able to provide those capabilities. So that's what I have to offer. I forgot to put up, I'm guilty of not putting up my contact information, but it's easy enough. Just use david.boyd@dhs.gov. It's real hard. david.boyd@dhs.gov. Thanks.
Okay, yeah, we had saved time for questions, but I think we started late, so I was trying to make time back up. So, anybody?
Fantastic panel. Thank you very much. Ms. Peavy, you said virtual solutions were costly. Is that software or scenarios?
I'm sorry, I couldn't hear the last part of the question.
What is costly? Is it the hardware, software, or the scenarios?
The answer is yes. Sorry about that, but the answer is yes. It's a combination of all of that. These guys would probably, in fact, Dr. Hamilton could probably give you a little bit more because they deal with a lot of the costs. But FLETC's budget, we only have like a $350 million budget. So when you take that and then try to put the simulations and things here, we have a hard time trying to afford that and come up with it. That's why we try to partner with these different agencies. Dr. Hamilton, would you like to add a little bit to that?
Yeah, I think, like I was kind of saying before, it's server cost, it's licenses, it's custom scenarios, it's the computers to run these. That's part of it. There's also, like I say, a long tail that these end users, that agencies need to account for. So there's training that goes, that's involved in training somebody that's going to be running this system or running the simulation. It's upkeep of those computers. It's updating them. Getting contracts in place to manage the licenses and to replace computers. It's getting ISAT involved, the IT guys involved to help manage them. So there's a lot of different expenses, not to mention the actual development and labor that goes into actually building this simulation the first time.
Another quick question for
It's also a data cost. If you think about the kind of modeling I was talking about, these are customized to each area. The terrain's different, the clutter's different, so you've got to spend a lot of energy and a lot of money in collecting the data to make it useful.
Thank you. Dr. Boyd, quick question. Have you looked at multi-protocol communications rather than just LTE or CDMA?
The answer is yes, we have. No, FirstNet has not. FirstNet has settled already on LTE. That is the way they're going to go. And the reason they are doing that is that that's the direction industry wants to go. So they have chosen LTE as the path they're going to use. I'll throw in a piece here, and that is the reason we think that there are more protocols than that ultimately you're going to have to use. And I think FirstNet will arrive at a big piece of this as well. Is that, first off, the whole world's not going to be LTE, and they're going to have to be able to ride on some of the existing commercial 3G systems. Second, land mobile radio is not going to go away. There is an unfortunate notion in some places, and we've had to provide some help to officials so they can tell their counties and the chiefs and the rest that no, LTE is not around the corner, FirstNet's not around the corner, it will happen, but it's going to take a long time. And it will not ultimately replace land mobile radio. It's a very narrow pipe. It's only 10 megahertz. And it has propagation characteristics that are different from much of land mobile radio. And there are all kinds of issues I won't get into except beyond, devices in LMR are 5-watt devices, 50-watt base devices. In LTE, you're talking about 100 or 250 milliwatt devices. There's a big difference. And so you're going to need these things. And so part of what we're looking at is how do we make these things interoperable with each other as we proceed forward and as we build out each of these systems.
Okay, thanks. And I know you may have more questions, and we kind of have run out of time, but we're going to break, and you'll be able to, hopefully these folks can stick around a little while during the break. You can catch them out in the hallway, perhaps, if you have a specific question. How about a round of applause for the panel?